Assalamu alaikum everyone. Today we are going to solve mathematics paper 3 9709. Let's start. The first question is to expand in ascending power of x up to and including the term in x square, simplifying the coefficients. So let me write down the journal formula first. The journal formula is 1 plus x whole power n, which is equal to 1 plus nx. X stands for the second the second term, and plus n minus 1 divided by 2 factorial into the second term square, plus this thing will continue up till as many terms as they are asking. So this is the formula. So if you look at this formula and the question that is given to us, we need to make the first term 1. So how can we make the first term 1? By taking 9 out of it. So if I take 9 from there, it will become 1 minus 1 over 3x, and the power will be whole, which is 1 by 2. After that, the power will come on both of them, which will be 9 power 1 by 2 bracket 1 minus 1 over 3x power 1 by 2. So 9 power 1 by 2 is 3. So the question will become 3 bracket 1 minus 1 by 3x to the power of 1 by 2. Now we have to expand 1 minus 1 by 3x to the power of 1 by 2 using the formula that is written above. So I'll write 3 as a common. So it will be 1 plus nx. So n is 1 by 2 multiply by x is the second term. The second term over here is minus 1 by 3. So it's minus 1 by 3x plus n into n minus 1. So n is 1 by 2 into n minus 1. 1 by 2 minus 1 will be minus 1 by 2. Divide this by 2 factorial into if you see over here, it is x square. So x square means that the square of the second term. The square of the second term will be minus 1 by 3 x whole square. We are just supposed to do up till the x square term. It was mentioned in the question up to and including the x square term. So that's up till we are going to expand only. So if I expand this bracket, it will be 1 minus 1 by 6x. Now if I do the simplification, the simplification for the first fraction will be minus 1 by 8. So it will become minus 1 by 8, and if I expand minus 1 over 3 whole square, it will become 1 over 9x square. Now let's do the simplification. 3 bracket 1 minus 1 over 6x minus 1 over 72x square. Now if you simplify and do the multiplication with 3, it will become 3 minus 1 over 2x minus 1 over 24x square. So this is the final answer for this. Yeah. Now let's move to the next question, question number 2. For question number 2, it says that by sketching a suitable pair of graphs, show the equation of cot 2x is equal to secant x has exactly one root. So for that purpose, we know that this is the first equation. I will make the graphs first separately for both of them, and then I will combine them together so that we can see that the intersection of the two graphs is only 1. That means that they have just one root. So the two graphs that basically I need to draw is y equals to cot 2x, and the other graph is y equals to secant x. So let me show you step by step the steps that I am going to follow. Step number 1. I will basically draw the graph. It's easier for me to memorize the basic graphs and then draw the further sketches of the graph. So, but if you directly remember the sketches of the cot 2x or secant x, that's easier for you and it will save your time as well. So I will draw first of all the graph of, I know that secant x is basically related to cos x, which is, so it is related to cos x. Let me write it cos x, and let me make, first of all, so that I have to make it the graph of cos x first, from where I will make the graph of secant x. So basically it's 1 over, so but I will first of all draw the graph of cos x. So cos x graph, this is y, this is x, so maximum value is 1. So that's how the graph is going to look like. And in the question, if you look at, he has given you the interval for which you are supposed to make the graph. So this is pi by 2. So I am only interested in this portion of the graph. So after that, I know that secant is basically, secant x is basically 1 over cos x. Now I will make the graph of secant x from this graph. So for this I will make the let me make the x-axis and y-axis. This is the x, this is the y. So this is where I have 1, and this is the place where I have pi by 2. Okay, now we can see that this is a reciprocal graph for the cos x. So for the reciprocal graph, you should know that the maximum point becomes the minimum point because it is 1 over something. Let me write it here. Maximum point will become the minimum point. So maximum point will change into a minimum point. Now look over here. If you look over here at this point, this is 1. So if you 1 divided by 1, it is automatically going to be a 1. But if you look at the next graph over here, this point, pi by 2, we have the value as 0. So if you put 1 over 0, it is going to approach infinity. So infinity means that this is going to be an asymptote. This is going to be an asymptote, and the graph is going to look like this. It is going to approach towards infinity like this. So this is how the secant x graph is going to look like. Now let's move to the second step, step number 2. For step number 2, I know that I have to draw cot 2x graph, but for that cot 2x is related to tan x. So first of all, I will draw the graph of tan x so that it can help me in drawing the graph of cot 2x. Now for the tan x, I have to draw it This is going to be pi by 2, this is 0, and this is minus pi by 2. These are the asymptotes. The graph is going to look like, so this is how a graph is going to look like. So now this is the graph how it is going to look like, but you all can see this is cot 2x, so I have to change this thing into tan 2x. So for tan 2x, if you could see, the stretch factor is 1 by 2. Stretch factor is 1 by 2. So what I will do, multiply the values of x with 1 by 2. So multiply values by 1 by 2. So the same graph, this is going to be the same graph, but the entire change is going to be, let me make it here. Yes, this is how the graph is going to be, but the value is going to be not pi by 2, it's going to be pi by 4 and pi by 4 over here, but we are interested in till pi by 2. So what will happen for the next portion? For example, if this is pi by 2, this is going to be the next portion of the graph. This graph is for tan 2x. This graph is for tan 2x. Now after that, we need to make the graph of the cot 2x. So for cot 2x, let's see, let me make the x-axis and y-axis. So this is for example pi by 4, and this is pi by 2. Now if you could see over here at this place, at this 0, and as it approaches towards pi by 4, both the places it is having if you put this thing, because we know that cot 2x is basically 1 by tan 2x, so it's basically the reciprocal. So as it approaches towards pi by 4, it is basically approaching, because it's approaching towards infinity, so 1 by infinity will approach to 0. So over here and over here in the start, at this place, this value of x is 0. So if it is 1 over 0 will be infinity. So at the start it is going to be at infinity, and as it approaches towards pi by 4, it is going to be 0. And if you look over here, this is at this specific place, it is coming back towards the value of x being 0. So 1 over infinity is again going to go towards infinity. So the graph is going to continue, and this is going to be infinity at pi by 2, and this is going to be the negative infinity, and this is going to be the positive infinity. So this is how the graph of cot 2x is going to be. Cot 2x. Now we need to make the graph of both of them together. Let me do it over here on the left side. I have to draw both the graphs together so that we can see that there is just one intersection, and one intersection would mean that there is just one root. So this is, for example, pi by 4, pi by 2. If I draw the graph of secant, it was continuity, and so it was starting from here, for example at 1. This was the graph for secant x, and the graph for cot 2x was this one at the bottom, which was infinity at this point, 0 over here, and back to infinity. So just over here for your convenience, if you see that there is just one intersection of the two graphs, it means that they have just one, they have exactly one root. So only one root, as there is just one point of intersection of both the two graphs. Now let's move to the B part. Part B says that show that if a sequence of real values given by the iterative formula, this is the iterative formula, converges, then it converges to the root in part A. So basically what we are supposed to do is we need to rephrase the given formula, this formula, the one that is given in this part. We have to rephrase it, and we need to get the same formula as in the part A. So it means it is going to be will be the solution for this. So it converges now. So what is this formula? Let me remove this iteration part from it. So it will be x equals 1 by 2 tan inverse cos x. Now first 2 will go to that side, it will multiply, it will become 2x equals tan inverse of cos x. So tan inverse is going to go that side, it will become tan of 2x equals cos x. Now we know that we are supposed to have it in the form of cot and secant, so we'll cross multiply, and by doing that I'll have 1 divided by cos x, which is equal to 1 divided by tan 2x. Cos 1 over cos x is secant x, and 1 over tan 2x is cot 2x. So this is a formula that we had at the start of the question in A part, and so it converges to that. Na? Question number 3 says the roots or the square root of 6 minus 8i can be expressed in the Cartesian form x plus this, where x and y are real and exact. This is important. X and y are real and exact. By first forming a quadratic equation, in x or y find the square roots of this and that in Cartesian form. Okay, let me write this equation, the complex number. It says 6 minus 8i square root, it is equal to x plus iy. Now we know that to remove this square root, I have to take the square on this side, and so I have to take the square on the opposite side as well. So left side square and square root will cancel out with each other, and it will become 6 minus 8i, and on the right hand side it will be x square plus I square y square plus 2 times xyi. Now if I simplify, it will be 6 minus 8i, which will be equal to I square is minus 1, so it will become minus y square plus 2xyi. Now we have the real part on the right side and the left side, on both the sides, so we will compare them, and so will we do the imaginary part as well. So if I compare the real parts first, it will be x square minus y square equals to 6, and if I compare the imaginary part, it will be minus 8 equals to 2xy. Now if I make x the subject over here, it will be x equals to minus 8 divided by 2y, and if I simplify it will be x equals to minus 4 divided by y. I'll substitute it in the formula on the left hand side. So if I substitute, it will become minus 4 divided by y whole square minus y square equals to 6. Expand it, 16 over y square minus y square equals to 6. Take the LCM, 16 minus y power 4 equals to 6y square. Rearrange it, it will become y power 4 plus 6y square minus 16, and it is equal to 0. Now do the factorization for this. It is going to be 8 and 2, so y power 4 plus 8y square minus 2y square minus 16 equal to 0. Y square is common, so y square plus 8 minus 2 common, y square plus 8. So the two brackets that we will have will be y square plus 8 and y square minus 2 and equals to 0. We'll put both of them equal to 0 separately. We'll have y square plus 8 equals 0 and y square minus 2 equal to 0. So y square will be equal to minus 8 and y square will be equal to plus 2. Taking square root of the left one is not possible, so we'll write not possible. For the right side it will become plus minus square root of 2. Now we have the y value. We just need to find the x value. X is minus 4 by y. We know that x is minus 4 by y. Just substitute it for both of them. We'll have the value of x if we put minus 4 divided by square root of 2. The other will be minus 4 divided by minus square root of 2. So minus 4 over square root of 2. The answer for the first one will be minus 2 square root of 2. For the second one it will be 2 square root of 2. So we have to write it in the form of x plus iy. So x is going to be, if I put the positive, x is going to be minus 2 square root of 2 plus square root of 2i. The other will be 2 square root of 2 minus square root of 2i. These are the two final answers that we will have. Let's move to the next question. Question number 4. Question number 4 says that solve the equation 5 power x equals to this. Give your answer correct to 3 decimal places. So we know that 5 power x is equals to 5 power x multiplied by 5 power 2 minus 10. So if I take everything on the left side, it will become 25 multiplied by 5 power x minus 5 power x minus 10, and it will be equal to 0. Now we have the like terms over here. These both are the like terms. The coefficients is 25 and 1. So 0 will be equals to 24 5 power x minus 10. Now 10 will be equal to 24 5 power x. This 24 will go to the other side. It will divide, so it will become 10 divided by 24 equals to 5 power x. So 10 divided by 24, that gives us 5 over 12. So 5 power x is 5 over 12. So we'll take log on both sides. It will be x log of 5 equal a log of 5 by 12. Now if I simplify them, this is going to give me log divided by 5. That is going to give me negative 0.54 up to 3 decimal places. So negative 0.5439, which will turn into 544. Let's move to the next question, number 5. Question number 5 says that the complex number u is given by this. Okay. Find the exact value of the argument of u. So basically, to have the argument of this thing, we can have multiple methods, but there can be two methods. I'll be solving this question by both the methods. You can choose whichever method you feel easy. One method is suggested purely by the marking scheme. The other method is the normal actual method. So let me write down, let me go through step by step so that it's convenient for you to go through it as well. So step 1. For the step 1, what we are going to do is we are going to do the rationalization so that we can disappear the denominator. Okay, so let me write down. Let me do the rationalization. U is equal to cos pi by 7 plus I sin pi by 7 and whole power of 4 divided by, it is cos pi by 7 minus I sin pi by 7. So to do the rationalization, I will multiply by the conjugate of the denominator. So for that it will be cos pi by 7 minus minus will change into a plus I sin pi by 7. Divide that by cos pi by 7 plus I sin pi by 7. Numerators will multiply with numerators, denominator with denominator. So if you look at the numerator, there is not going to be any change because both of them are the same thing. The power will just going to increase. So it will become cos pi by 7 plus I sin pi by 7 whole power of 5 divided by the denominator is one is positive and the other is negative, so we can write it as cos square pi by 7 minus, it is going to be I square sin pi by 7, sin square pi by 7. So after that we are going to simplify the denominator further. There is not going to be any further change so far in the numerator. So I sin pi by 7 whole power 5. In the denominator it's going to be the negative is going to change into a positive because I square is negative 1. So we'll have cos square pi by 7 plus sin square pi by 7. So now if you look at the denominator, we can see that it is cos square. The angle over here is same in both of them, in this one as well as in this one, and we know that sin square theta plus cos square theta is 1. And why is it 1 when both of them have the same angle? So let me write it here. If same angle with cos square theta plus sin square theta it will be 1. So the denominator is going to be 1. Now I will be left with only the numerator, which will be cos pi by 7 plus I sin pi by 7 and whole power of 5. Now I have to further for this I have to add another page. Let me add another page. Okay. Now what are we supposed to do? We are up till here, but we are supposed to find out the exact value of the argument for u. So now we have basically cos pi. We have this thing cos pi by 7 plus I sin pi by 7 and whole power of 5. This is what we have. So for the complex number without power, let's do it without power first. Let me do it without power first. If it was without power, then I'll come on to the revision of that thing. If we have multiple complex numbers which are multiplying, what to do with that? So if we have cos pi by 7 plus I sin pi by 7. So we know that the modulus argument from where it starts, you have it as 1. So something like you know that something like your R modulus argument is formed, which is R cos theta plus I sin theta. So the modulus argument from right, if you say the modulus is 1 and the angle inside is basically the argument, is itself the argument. So the argument from here, the argument of this thing is going to be pi by 7. Now but we have above, if you see, this is the argument for this one, cos pi by 7 plus I sin pi by 7. But if the actual question is having a power of 5, so now for the power is 5. Now what will you do if the power is 5? Let me just revise that thing, that if, for example, if you have two complex numbers which are multiplying, the arguments of those complex numbers are going to add. So if, for example, if you have u square, it will mean that argument of u plus argument of u. Now since we have in this particular question, we have the power as 5. The u is basically having this thing is having a power of 5. So what is happening? It is this, that the same complex number is multiplying with itself like 5 times. So the argument is going to add with itself 5 times. Or you can simply multiply it with 5 as well. So it will be 5 pi by 7. This is the argument of u. This was method 1. Now let's do the other method as well, which is suggested by the marking scheme. Method number 2, let me do it here. Method 2 suggested by the marking scheme. Now we know that the complex number that we had was u equals to cos pi by 7 plus I sin pi by 7 whole power of 5. It was power of 5. it is having a power 4. Sorry, its power of 4 divided by cos pi by 7 minus I sine pi by 7. This was the question. Now if look over here, that look at the complex number, there is a numerator and there is a denominator. So we are going to treat both of them separately. So let's look at the numerator first. We'll find the argument for the numerator and then we'll find the argument for the denominator and then we'll simplify it to find the further. So it is, if you look at the numerator, it is having a power of 4. The complex number is having a power of 4. So if you look at the thing that is inside the bracket, that is again cos pi by 7 plus I sine pi by 7. So if you could remember from the previous methodology that we did, the argument for this is going to be pi by 7. So if this argument is pi by 7, the argument for the numerator, let me write down, argument for the numerator will be, it is having a power of 4, so simply I will multiply it with 4, or you can add it as pi by 7 and pi by 7. This is going to be the answer for the argument for the numerator, not the complete complex number. Now I have to do the same for the argument of the denominator. Argument for the denominator. Now for the argument of the denominator, we know that the denominator is cos pi by 7 minus I sine pi by 7. The important thing is that you should know that the center sign, the one that I just highlighted over here, this sign has to be always a positive sign. This, let me write it here, this always should be positive. So in order to make this positive, if I want to make this positive, I have to write down it as cos pi by 7 plus I sine minus pi by 7 because of the property of sine. So we can see, but if you remember, if you see over here now that the angle of both of them, these angles are not the same. So you remember for the modulus arguments, the angle has to be the same. The angles should be the same for modulus arguments. So if in order to make both the angles same, we know the property of cos, and the property of cos is that, for example, cos pi by 7, it will be equal to, you can even check it in the calculator as well, that cos pi by 7, it will be equal to cos of minus pi by 7. So I will just simply change this thing over here and it will become cos of negative pi by 7 plus I sine of negative pi by 7. So if you could see over here, both the angles are same now. The argument for this is going to be negative pi by 7. Now we need, one is for the numerator, this argument is of the denominator. Now we have to find the argument of the complete complex number u. So since both of them are dividing, so what we will do, the argument of the numerator, which was 4 pi by 7, minus the argument of the denominator, which is minus pi by 7. Why are we subtracting? Because both the arguments were dividing, both the complex number were dividing. So that is why this is the negative sign over here. Two complex number were, why this minus sign? Two complex numbers were dividing. Now we'll add them, so it will become 5 pi by 7 as the argument of u as the final answer. I hope it is clear. This was question number 5. Yeah, there is another part for question number 5, and that's the B part. The B part says that the complex number u and u star, conjugate of the u star for that, are plotted on an organ diagram. Describe the single geometrical transformation that maps u onto u star and state the exact value of u star. So basically u is x plus I y, and u star will be the conjugate of that, which will be x minus I y. We also know the argument of this. Argument of u is 5 pi by 7. This is the first step. Now let's make an organ diagram over here. If I make the organ diagram, I know that the u is going to be in the first quadrant because x and y, both of them are positive. So for example, if this is u, the angle over here, we already know this angle is 5 pi by 7. And if you look at u star is going to be here, where the value of x is still positive, but the value of y, the value of x is positive and the value of y is negative. Imaginary value is negative. So this is that's the transformation that is happening from here. It is going up till here. The angle over here, this angle is going to be negative pi by 7. So what we need to do is we need to describe. Okay, so so basically it's reflection. So it's the reflection across x-axis, but since it's not the x-axis, it's the real axis, so it's the real and imaginary axis, na? So you will write down reflection across the real axis, and we need to mention the exact value of the argument. So argument of u star, it is going to be minus pi by 7. That was it. Let's move to the next question. Question number 6. Okay, so question number 6 says that the variable x and y satisfy the equation this. So this is the equation that we have, where a and b are constants. The graph of ln y against x is a straight line. It's a straight line. The graph over here is a straight line. Point 0.5 and 2.2, this and that. Find the value of a and b. Give each value up to correct to one significant figure. So what is the first thing? We know that this a and this line is a straight line. So we'll convert the given equation over here. We'll convert it into a linear equation, a straight line equation. So this is the first step. Let me write step number 1. And step number 1 is to convert the given equation to straight line equation. Straight line equation. Now we have given this equation ay equals to b power x. So I'll make y on one side because y equals to mx plus c. So it will be y equals to b power x divided by a. Now I'll take log on both sides. It will become ln y equals ln of b power x over a. Now if I simplify, it will become an equation of ln y equals ln of b power x minus ln of a. Now if I further rearrange it, the equation is going to become ln y equals x ln b minus ln a. Now the equation of a straight line is y equals mx plus c. So basically we have x and x, and this ln b is basically the gradient part. Now we also have the coordinates of 2 points, which is 0.5 comma 2.24. The other is 3.4 comma 8.27. I'll substitute them both into the above equation, solve them simultaneously to find the value of a and b. Now if I put the first one, it is ln y. Oh yeah, remember, if you see over here the graph ln y, these values over here, these values are already given for ln y, and this value is related to x. So it is ln y and x values that are given as a coordinates. So no need to change, take ln again. So ln y is 2.24, which will be equal to 0.5 ln b minus ln a. Similarly, 8.27 equals 3.4 ln b minus ln a. Now we'll make a the ln a the subject, we'll substitute it in the other. It will be ln a equals 3.4 ln b minus 8.27. Now let's substitute this one into the other, into this. So it will be 2.24. Let me put an arrow. So 2.24 equals 0.5 ln b minus, since I am substituting it, I'll put a bracket. It is 3.4 ln b minus 8.27. Now 2.24 equals 0.5 ln b minus 3.4 ln b plus 8.27. So like terms on both sides, 2.24 minus 8.27, which is going to give me minus 6.03, and on the right side it will be 0.5 minus 3.4, because they are also the like terms, minus 2.9 ln b. Negative and negative both will cancel out. Now it is going to be 6.03 divided by 2.9, which will be 2.07 93, which will be equal to ln b. Now we'll take antilog, shift ln, that is going to be antilog 0 of this answer, that is going to be 7.9989. We are supposed to write up to how many significant? 1 significant, so it will be 8. So the value of b is 8. For the value of a, we'll substitute it here. It is ln a equals 3.4 ln of 8 minus 8.27. So we need to take ln of this, multiply it with 3.4 minus 8.27. So it is going to be minus 1.2003. It is ln a. Now after that, if we take antilog, for this, the value of a up to 1 significant figure, it is 0.3. I hope it is clear to you. Let's move on to the next question. Question number 7, part A. Question number 7, part A says that show that the equation this may be expressed as tan power 4 x minus 2 tan square x minus 3 for tan is equals to not 0. So for that, okay, there is very clear indication that we need to convert this tan 2x into a simple tan, which is just a square. So we know from the formula booklet, data booklet, we know that tan 2x is equal to 2 tan x divided by 1 minus tan square x. So let's do the replacement over there. The actual equation is tan cube x plus 2 times, in place of tan 2x we'll replace this thing, which will be 2 tan x divided by 1 minus tan square x minus 3 equal to 0. Now after that we'll simplify. It will be tan 3x into 1 minus tan square x plus 4 tan x minus 3 bracket 1 tan square x equal to 0, and the LCM was 1 minus tan square x. Now we'll cross multiply. The denominator is going to go to the other side. It will become 0. We'll simply do the expansion of the numerator, which will be tan cube x minus tan 5x plus 4 tan x minus 3 plus 3 tan square x, and it will be equal to 0. Now like terms, tan do we have a like term? We do have a like term. No, we don't have a like term. So let's simplify. Let's arrange it. This is the arrangement. We are now let's do the arrangement for this. For the arrangement, it was this and this. This is basically tan over here, which I have skipped. So this is the tan over here, not 3. 3 is the one that we need to make. So tan x, so it will become tan x plus tan cube x, and it will be equal to 0. Now we do have like terms. So if I arrange the like terms, it will be minus tan 5x. These are the like terms, this and this. So they are going to add and give me 2 tan 3x plus plus it's going to be further, and it's going to be, if I can simplify these two as well, and they can give me 3 tan x and equal to 0. Now what I can do is I can take negative tan x as a common. So if I take negative tan x, I'll have tan 4x plus 2 tan square x plus 3 equal to 0. This negative tan x will go to the other side, it will divide, and I will be left with tan 4x plus 2 tan square x plus 3 equal to 0. And this is what I was supposed to show. This is no, there is a negative sign, there is a positive sign. I have definitely made some mistake. Tan square, this is tan square, and this is, since I have taken a negative, so it has to be a negative inside. So yeah, fixed. So yeah, this is what we are supposed to do. Let's do the B part. Hence solve the equation tan 2 theta plus 2 tan 4 theta plus this. So basically we are supposed to solve tan 4 2 theta. Everything is now being changed. Every x over here, if you look over here, this is the common mistakes that students do. It's being converted into double. So tan 4 2 theta minus it was 2 tan square 2 theta minus 3, and it is equal to 0. The angle is basically changed. So what we can do is we can let y be as tan square 2 theta, and say it, the equation will become it is going to become y square, which will be minus 2y minus 3 is equal to 0. So the two factors will be minus 3 and 1. So y square minus 3y plus 1y minus 3 equals to 0. So y can be taken common. 1y minus 3 equal to 0. The brackets will be y plus 1 equal to 0 and y minus 3 equal to 0. So y will be equal to minus 1 and y will be equal to plus 3. Now we know that y is basically tan square 2 theta. Let me just substitute it here. But for tan square 2 theta equals negative 1, tan square 2 theta equals plus 3. Negative side square root on the left side is not possible. Let me write it here, not possible. For the right hand side I'll simplify and it is going to give me 2. If I take the square root, it is going to give me 2 answers. It will be tan 2 theta equals to square root of 3 and tan 2 theta equals to negative square root of 3. Now I have to make the basic angle first. This is going to be for the first one. Tan is positive in the first and the third. So these are the basic angles, the alphas. And for this one, the tan is negative in the second and tan is negative in the last. So these are the two basic angles. If I do the tan inverse, but for that let me do the let me find the basic angle first. Remember, the basic angle is supposed to be in terms of radians. Change your calculator mode to radians first. So tan inverse of square root of 3, that will be pi by 3. Tan inverse, this will be pi by 3, pi by 3, this will be pi by 3 and pi by 3. Now if you look at the start of the question, if you look over there, it says the domain is from 0 till pi, from 0 less than x less than pi. Yes, theta, for theta, sorry, that's the for theta. But over here we have 2 theta, not theta. If you look over here, it's tan 2 theta. So we will change the domain of the question, will multiply everything with 2. So it will become 2 theta less than 2 pi. So now we are supposed to go up till 2 theta, which means one complete circle for both of them. So one angle is going to be this one. One angle is going to be this, which is the value of theta. Theta, one value for theta is this. The other value of theta from the first one is this, which means it is pi plus pi by 3. If you look over here on the right side, there are two thetas again. One is this theta, the other is this theta. So if I find both of them, it will be first theta will be the first theta is going to be, the first theta will be pi minus pi by 3, the other will be 2 pi minus pi by 3. Now if I simplify this one, it is going to be 3 minus this, it is going to be 2 by 3 pi, and this is going to be 6 pi minus 1 pi, which will be 5 pi by 3. And from here, this is going to be theta will be pi by 3 comma 4 pi by 3. So these are the four exact values of theta that we were supposed to find out. Let's move on to the next question, question number 8. Question number 8 says that the parametric equation of a curve are this and that. Show that dy over dx is this. So let me devise that into two steps. Step number 1. In the first step, I have two equations with me in terms of x, which is x equals to tan 2 theta whole square, and the other equation for y is cos 2 theta. I will find out the derivative of both of them, which will be dx over d theta dt. That will be first I will bring the power before, and I'll reduce 1 from the power, which will be 1 into the derivative of tan. Derivative of tan is secant square 2 theta multiply by the derivative of the angle, which is 2. So dx over dt will be 4. 2 times 2 is 4 times tan 2 theta into secant 2 square 2 theta. Now I have to do the same for y as well. I have to find dy over dt. That's very simple. The derivative of cos is minus sine, so minus sine 2t multiply by the derivative of the angle, which is 2. So this will be minus 2 sine 2t. This is the derivative of y with respect to t. Now step number 2. Step number 2, we were supposed to basically show dy over dx. So dy over dx will be equal to dy multiply by dx over here in the chain rule. So but what will come over here? Dt, and here it will be dt. Now dy over dt I already have it, which is minus 2 sine 2t multiply by, for the other one it is, since it is dx over dt, but I need dt over dx, so I have to take the reciprocal of it, which will give me 1 divided by 4 tan 2t multiply by secant square 2t. Now I have to bring it in terms of cos only, so I have to convert all of them. So the first, this thing is going to be written 2 sine 2t as it is multiply by I know 1 divided by 4. I know tan is basically sine over cos, so we'll have sine 2t. The cos is it's going to go in the numerator. It is going to be 2 cos 2t multiply by secant is basically 1 over cos, so we'll have cos square 2t. Yes. Now we'll do the simplification. If I do the simplification, this and this will cancel out. This will be 2 and this will be 1. So I will be left with just minus 1 divided by 2 cos cube 2t. This is the dy by dx. And I think that's, yes, let's move to the next part. For the next part it says, hence find the equation of the normal to the curve at the point where t is this. So for finding out the equation, we need to have the gradient and we need to have the coordinates of that specific point. So let me write it in the form of steps so that it's easy. Step 1, I have the 2x over here, which is tan 2 theta whole square. X is tan 2 theta whole square and y is cos 2 theta. So I'll use these to find the value of the coordinate. I know that t is pi by 8. Substitute over here. X is equals to 2 times pi by 8, which is pi by 4. So tan of this, tan pi by 4 is 1. So 1 square is 1. Similarly, if I took 2 times, this is going to be pi by 4. Cos of pi by 4 is square root of 2 by 2. Now I have the coordinates. Let me write them in the form of the a point, which is 1 comma square root of 2 by 2. Now after that, I have to have the, for equation I also need to have the gradient. For the gradient, let me write down step 2. For the gradient, it's dy by dx. We already have the dy by dx, which is minus 1 by 2 cos into which is cos of 2 times pi by 8 and whole power 3. Now if I substitute, it's pi by 4 cos of pi by 4 we already know, and then we need to take the cube. Okay, so the cube is square root of this multiply by 0.5. That gives us the gradient to be minus 1 by 8 square root of 2. So this is the gradient of the tangent. This is the gradient of tangent, but we need to find out the gradient of the normal. So the gradient of the normal will be the negative reciprocal of this. So the denominator becomes the numerator and numerator becomes the denominator. So it will become, and the sign will also change. So it will become 8 over square root of 2. So if you simplify, it will be 4 square root of 2. This is going to be the gradient, but we need to give our answer in y equals to mx plus c form. So it will be y equals, so now y minus y1, the coordinates are y minus y1 square root of 2 by 2 equals m, which is this, the gradient, and into x minus x1, which is 1. Simplify, y minus square root of 2 by 2 will be equals to 4 square root of 2x minus 4 square root of 2. Bring like terms to one side. 4 square root of 2 minus 4 square root of 2 plus square root of 2 divided by 2. So y will be equals to 4 square root of 2x. So minus square root of 4 minus 4 square root of 2 plus square root of 2 divided by 2. The answer is minus 7 square root of 2 divided by 2. This is the final answer. We were supposed to show it in the form of y equals to mx plus c. Let's move to the next question. Question number 9. Question number 9 says, with respect to the origin O, the points A, B and C have position vectors given by this, this and this. The point D is such that ABCD is a trapezium with DC this equals to 3AB. Find the position vector D. So let me do it in steps. So step number 1. So for the step number 1, I need to first of all find out AB. So how can I find out AB using the position vector? You are very much familiar, which is OB minus OA. So OB is already known, which is 0, 4, 1 minus OA, which is 2, 1 minus 3. So if I simplify, it will be minus 2, 3 and 4. So this is the vector A, B. Now step number 2. Step number 2. For step number 2, let me do it here. For step number 2, I have to use the given information above, which is which is DC equals 3 times AB. I have to convert this DC into the position vectors. This is DC, so it will become OC minus OD, which will be equal to 3 times AB, and the AB vector is minus 2, 3 and 4. So OC is known to me. OC is minus 3 minus 2, 2. Let me substitute minus 3 minus 2, 2. And in place of OD, I can even write XYZ, or I can simply write down OD as well. This is going to be scalar multiplication of vectors minus 6, 9 and 12. Simplify to find the value of x, then y and then z. For x, it is going to be minus 3 minus x equals minus 6. So x will be equal to minus 3 plus 6. So it is going to be plus 3 as the value of x. For the value of y, it will be minus 2 minus y equals 9. So y will be equals to minus 2 minus 9, and the value of y will be minus 11. Similarly, for the value of z, it will be 2 minus z, which will be equal to 12, and z will be equal to 2 minus 12, which will be minus 10. Now we can write it in the form of a position vector OD. So OD as a final answer would be 3 minus 11 and minus 10. This is the final answer for OD. Now if you look at the next part, let's move to the B part. B part says that the diagonals of a trapezium intersects at point P. Find the position vector P. Okay, so this is a lengthy thing. Yes, so let's try to visualize it. Try to visualize a bit. For example, this is the trapezium that we have, AB CD. This is going to be A, this will be B, this is C and this is D. He says that if there are diagonals of the trapezium, they are going to intersect at the point P. This is the intersection P point. We need to find out the position vector P. Now this is Let me do it step by step. This was the visualization was step number 1. Let's visualize it as let's do the second step. For the second step, we basically need to find out the point P, which is the intersection of the two vectors AC and DB. So to find this intersectional point P, for this 3D basically diagram, we basically need to form vectors equation for AC and BD. So, and then we will solve both the equations simultaneously to find the that position vector P. So let's first of all make the two vector equation, step number 3. So for step number 3, and we are going to do this step for finding the equation for BD or DB, or DB, better it would be for DB. And how this is going to be DB, it will be equal to DB will be equal to DO plus OB. DO we already know, OD we found out, so it is going to be the negative of that. It will be minus 3, 11 and 10. OB we already have it in the question. OB is 0, 4 and 1. So 0, 4 and 1, which will give you minus 3, 15 and 11. This is the equation for DB. Now we want to find out the vector equation for DB. We will, since it's a 3D shape, so we will find vector equation DB. So for vector equation DB, it will be R equal A plus TP. So for finding R, A is going to be a point, and we can take any point. DB, we can take the point B. We can use the vector point for B, and similarly for P is going to be the passing point. This is going to be the passing point P. Now let's form it. R will be equal to A. A is the coordinate position vector B, which is 0, 4 and 1. 0, 4 and 1 plus T, and P we already have it, and that is minus 3, 15 and 11. Now we have to form, this was the vector equation for DB. We have to form the vector equation for AC as well. For that, we'll first of all find out AC. How can you find out AC? It is OC minus OA. OC we already know, minus 3 minus 2 and 2, minus OA is 2, 1 minus 3, 2, 1 minus 3. If I simplify, it will be minus 5, minus 3 and 5. So this is the this is the equation for AC. Now we need to find out the vector equation for AC. Vector equation AC, which will be R equals, the point we can take is C, which is minus 3, minus 2 and 2. Minus 3, minus 2 and 2. We already have used T. Let's use S over here. We already have the equation for AC, -5, -3 and 5. Now we have the vector equation for both of them. We'll put them equal to each other. uh, uh, if we put we'll put both of them equal to each other. This is going to be step number 4. Put them both equal. So it will be 0 plus minus 3t. It will be 0 minus 3t, which will be equal to -3 minus 5s, 4 plus 15t, which will be equal to -2 minus 3s, 1 plus 11t, which will be equal to 2 plus 5s. Now we'll use the first two equations. If I use the first two equations, it will help me in finding the value of t, or we can find the value of s. So it will be, I'll use the first, -3t equals -3 minus 5s, and t will be equal to -3 minus 5s divided by -3. Similarly, I'll use the other one. This is the first in terms of t. I'll use the second one, 4 plus 15t. I'll take the 4 in the first step to the other side. It will give me 15t equals -6 minus 3s. So t will be -6 minus 3s divided by 15. These are the two equations in terms of t. I'll put them both equal to each other. Let me do it here. If I put them both equal to each other, this is going to be 15 will come onto this side. It will be 15 bracket -3 minus 5s equals to -3 bracket -6 minus 3s, and if I simplify, -45 minus 15 5s are 75s equals +18 plus 9s. Collect the like terms. S we can take -45 minus 18, 9s plus 75, 84s, and -45 minus 75, which will be sorry, it's -18. It is going to be -63. So the value of s will be 0.75. So you can also find the value of t. So but there is no need to find the value of t. Why? You just need to find the position vector OP. For that, what you can use is, you can substitute this value in any of the above equation. In the first, in this one, this AC, which is having the vector equation for AC. This is going to help you in finding the position vector OC. So OP will be -3 minus 5 bracket 0.75, -2 minus 3 into 0.75, 2 plus 5 into 0.75. So -3 minus 5 into 0.75. This is going to give me this is minus, I have made it. This is going to give me the final answer for this vector OP as 0.3 by 4 for the first. If I change the second, it will be -2 minus 3.75, which is 1 by 4. This is not a negative sign. it's 2 plus 5 bracket minus 0.75, which will be minus 7 by 4. So this is the position vector OP. The C part says, let's move to the C part. C part says, using a scalar product, calculate angle ABC. So for finding the angle ABC, basically he is saying, that's how the diagram looks like. This is the angle B, this is A, and this is C. This is the angle theta that we need to calculate. Always remember that the direction of the vectors have to be away. They need to go outside the angle. So let's do the first step. We know the formula. Let's do the we need to basically find out the vectors AB and BC. So find out AB. I think we already are familiar. I think we found out AB somewhere. Yes, it's minus 2, 3, 4. AB is, but this is BA. This is BA. Let me write this. Minus 2, 3, 4. This is going to help us in finding out BA, which will be 2, minus 3, and 4. Similarly, the other vector is BC. And I think we don't have BC, but we have OB and OC. We can find out BC, OC minus OB. So OC will be OC minus 3 minus 2, 2, minus 3 minus 2, 2, minus OB is 0, 4, and 1. It's 0, 4, and 1. So it will be minus 3, minus 6, and 1. So this is the vector BC. Now the last step is that we are going to use the formula. According to the formula, the product is over here. So the product will be minus 3, minus 6, and 1 dot the other vector, which is 2, minus 3, and 4. The magnitude of both of them on the right side, they need to multiply. The magnitude will be the square, 2 square, 4 plus 9 plus 16, which is going to be 29. Similarly, 9 plus 36 plus 1, which is 46 cos theta. Now, and on the left hand side, it will be minus 6. You multiply x with x, y with y, and z with z. So minus 6 plus 18 plus 4. This is going to be this is minus 4. Yes, so it's going to be minus 4. It's going to be square root of 29 times square root of 46 cos theta. So negative 6 plus 18 plus minus 4, which is 8 divided by so 8 divided by square root of 29 into square root of 46. The answer is 0.2. Cos theta is 0.21903, and the value of theta is 77.3 degrees. Let's move to the next question. Question number 10. Question number 10 says, this is having multiple parts and 11. Okay, question number 10 says that a balloon is in the shape of a sphere and the volume is V and radius is R. Air is pumped into the balloon at a constant rate. So, okay, which is 4 pi starting when time is 0. At the same time, air begins to flow out of the balloon at a rate of this. So according to this information, and this information together, it is basically telling you that the volume, the rate of change of volume, which is constant rate, it says this is flowing in, so this is positive and this is negative, so this will be 40 pi minus 0.8 pi r. And after that he also says that we need to show that dr over dt is this. The balloon remains a sphere all the time. So this is the step 1. Step number 2 is that we should remember the volume of sphere. The volume of sphere is 4 by 3 pi r cube. Now if I find out dV over dr, it will be 4 pi r square. Now I'll use the chain rule to find out dr over dt. So dr over here followed by dt over here. I'll put dv and dv over here. Now I already have dv over dt, but dr over dv, yes, I already have, but I'll flip it, so it will become 1 over 4 pi r square multiply by 40 pi minus 0.8 pi r. But I have to show it as this. So you see that the numerator does not have a pi, so I'll take pi as a common, and the numerator also does not have 0.8, so I'll take 0.8 pi common. So 40 divided by 0.8 is 50, so inside I'll have 50 minus r divided by 4 pi r square. Now pi and pi will cancel out. If I divide 0.8 by 4, it gives me 1 over 5. So it is 1 in the numerator. I am left with 50 minus r divided by 5 r square. The second part says that find the quotient and the remainder when r square is divided by 50 minus r. So simply I have to divide using long division. So inside I will write down 5r square. Outside I will write minus r plus 50. I will first multiply with minus r. So it will give me 5r square minus 250 r. Now since there is no r in the above one, so it's 0 r. Further, if I simplify and change the signs, positive to negative cancel out, this will be positive. I'll be left with 250 r. Now I will multiply both of them with I will multiply with negative 250. So negative 250, if I multiply, I get 250 r plus 250 multiplied by 50 is going to be 12500, but the sign is going to be negative 12500. The signs are going to reverse. This will cancel out. This is going to be positive, and I'll have 12500. This is the remainder and this is the quotient. Now this is the quotient and this is the remainder. In the C part, it says solve the differential equation in part A, obtaining an expression for t in terms of r. So in part A, the differential equation was this, dr over dt. Let me write it here. It was dr over dt, which was 50 minus r divided by 5r square. So in the first step, I have to bring the r terms on one side and t onto the other. So if I bring it on the left side, it will be 5r square over 50 minus r, and dr on the left side and dt only on the right side. Now since I need to make it an equation, so what I will do is I will integrate on both sides. I'll do the integration here and I'll do the integration on the the right side. But if you see over here, there is one more thing that we need to do, and that is that if we are dividing the fractions and they cannot be simplified, we can further simplify it using the thing, the quotient and the remainder and the divisor. So we'll segregate it. We have it from the previous part, the remainder and the quotient we have it. Let me write it over here. Integration of minus 5r square. Yes, it's minus, no, it's not minus, qx, na? Quotient is minus 5r, sorry, it's minus 5r minus 250 plus the remainder is 12500 divided by the quotient, which is the same 50 minus r dr equals to integration of 1 dt. Now we'll take the LCM. We can simplify basically the left hand side by doing the integration. So if I do the integration of each one of them separately, it will be 5 minus 5r square minus 250r plus 1250 is a constant. I'll take it as a constant, ln of 50 minus r divided by the differentiation of that, which is minus 1, which will be equal to t, and since there is no limits, I'll add a constant plus c. So I know that he told me the radius and the time, which were both 0. T is 0, r is also 0. It will help me in finding the value of c. The first term 0, the second term 0, the third term will be minus 12500 ln of 50, and this will be the value of c. Now I have the value of c. The equation will be t equals minus it is 5 by 2r square minus 5 by 2r square minus 250r minus 12500 ln of 50 minus r. It's subtracting on that side. When we'll bring it to this side, it will add 12500 ln of 50. Now we can further simplify it as well, so that there is just one logarithmic term. It will be minus 5 over 2r square minus 250r. We can take 12500 as common, and we will be left with ln of 50 minus ln of 50 minus r. Since they are we'll divide them, so we'll be left with the final answer. Let me write the final answer: minus 5 over 2r square minus 250r plus 12500 bracket ln of 50 divided by 50 minus r. This will be the final answer. In the next part, we need to find the value of t when the radius of the balloon is this. So we need to find time when the radius is 12. So just substitute radius as 12 in the above equation. So it will be minus 5 over 2 into 144 minus 250 into 12 plus 12500 bracket ln 50 divided by 50 minus 12, that is 38. put this thing in the calculator. Minus 2.5 into 144 is minus 360. 250 into 12 is 3000 minus 3000. 12500 into ln of 50 over 38. This is 3430 point something. So minus 360 minus 3000 minus this, that is going to give the final answer. Multiply it with this as well. Yes, so the final answer of this time will be 70.5. Okay, so let's move to the last question, question number 11. And in the last question it says that we have a function, we need to find out the f dash of x and hence find the exact coordinate of the stationary point. Stationary point means that we need to find out that dy by dx equals to 0. For this we know that f of x is this. We know that if d over dx of u over v, we can find it as v u dash minus u v dash divided by v square. So this is the function given to us above. Let's find the derivative for this. F dash of x will be then the denominator as it is, which is e raised to the power of 2x minus 3 e raised to the power of x plus 2 into the derivative of the numerator. The derivative of the numerator will be 2 e raised to the power of 2x multiply by the derivative of the power, which is 2, minus the numerator as it is, which is 2 e raised to the power of 2x multiply by the derivative of the denominator. The first thing, e raised to the power of 2x as it is multiply by the derivative of the power, which is 2, minus 3 e raised to the power of x as it is. The derivative of the power is 1, so no need. The constant will be 0 divided by the square of the denominator. Yes, so if it further simplify, it is going to be, if I expand the numerator, it is going to be 4 e raised to the power of 4x minus 12 e raised to the power of 3x plus 4 to the 8 e raised to the power of 2x minus, if I expand this, it's going to be 4 e raised to the power of 4x plus 6 e raised to the power of 3x divided by the denominator, which is e raised to the power of 2x 3 raised to the power of x plus 2 whole square. If I simplify, these two are the like terms and they can simplify. Yes, there are other as well. They are going to give me minus 2 this, it will be 8 e raised to the power of 2x 6 e raised to the power of 3x divided by the denominator will be as it is. Now this is the derivative and we know we need to find out the stationary points. So stationary points will be dy by dx equals to 0. So we will put this thing equal to 0. 8 e raised to the power of 2x minus 6 e raised to the power of 3x divided by e raised to the power of 2x minus 3 e raised to the power of x plus 2 whole square. Cross multiply, this will be 0 equal to 8 e raised to the power of 2x minus 6 e raised to the power of 3x. We have common 2 e raised to the power of 2x is common, So 2 e raised to the power of 2x, it will be 4 minus 3 e raised to the power of x equal to 0. So 2 e raised to the power of 2x will be 0. It cannot be further solved, so we will ignore it. But 4 minus 3 e raised to the power of x equals to 0. If you further simplify, this will be 4 e raised to the power of 3 e raised to the power of x. So e raised to the power of x will be 4 by 3. We'll take ln on both sides, which will give us x is equals to ln 4 by 3. This is the x coordinate of the stationary point. We need to find out the y coordinate as well. So to find the y coordinate, it will be y equals to 2 e raised to the power of 2 times ln 4 by 3 divided by e raised to the power of 2 times ln of 4 by 3 minus 3 raised to the power 3 e raised to the power of x e to the power of ln 3 by 4 plus 2. So the power, this power is going to become this multiplication is going to become the power. So this is going to become 2 e raised to the power of ln 16 by 9. It's going to become 16 by 9 divided by simply this power is going to also become this multiplication is also going to become the power. So e raised to the power of ln of 16 by 9 and this 3 is also going to become the power e raised to the power of ln 3 power 3 is 27 divided by 4 power 3 power 3, it's going to be no, this is before that, so this cannot be the power then, but yes, this e and is ln will cancel out, so this 3 and 3 by 4 they will multiply plus 2. So further it will be this e and this will cancel out, so in the numerator we'll have 2 times 16 by 9 divided by this, and this will cancel out 16 by 9 minus 9 by this is 3 by 4, sorry, this is 3 by 4 or 4 by 3 by not 4, it's 4 by 3. I have written it wrong. It's ln of 4 by 3. These will cancel out. This will be left with just a 4 and plus 2. If I further simplify, this is going to give me the value for y as minus 16. So the coordinates of the stationary point will be ln of 4 by 3 comma minus 16. The coordinate of the stationary point. Anything further? No. The last part says that use the substitution u equals this and the partial fraction to find the exact value of this. Let me divide it into a few steps so that it's easier. Step number 1, let me do the first step. U is equals to e raised to the power of x, and du over dx will be also e raised to the power of x. I'll bring the x term to one side. It will be if I simplify, it will be 1. If I further simplify, it will be the u is going to be here. It will become 1 over e raised to the power x du equals to dx. Basically I need to make the x subject because that's where I am going to replace it, and I know that e raised to the power x is basically u, so 1 over u is du is this. So I'll replace the dx with 1 over u du in the above. So this is basically the first step, step number 1. Step 1. This is the first step. Now step number 2. Step number 2 is to change the limits as well. So I know that x is having a limit of ln of 5. So and I know that so u will be having e raised to the power of ln of 5. So it will give me the value of u as 5. Similarly, x is also having the limit as 3, ln of 3, sorry. So you will have e raised to the power ln of 3, which will give me 3 as the other value. So this was step number 2. Now step number 3 is the function that we have. We just need to replace the e raised to the power x with u. So the function that I have with me is this function 2e raised to the power of 2x, 2e raised to the power of 2x divided by e raised to the power of 2x minus 3e raised to the power of x plus 2. I'll replace e raised to the power of x with u, so it will become 2u square divided by u square minus 3u plus 2. This was step number 3. Step number 4. Step number 4, I will replace I'll replace it over here in the integration portion. So with all the limits and everything, the upper limit is 5, the lower limit is this. It will be 2u square divided by u square minus 3u plus 2. In place of dx, I will put 1 over u du. This u and this u will simplify. I'll be left with 5 and 3. If I simplify, it will be 2 divided by u square minus 3u plus 2 du. Okay, so for this now I have to further simplify but first I have to do the factorization. If I do the factorization, it will be minus 3 minus 2 minus 1. So the two factors will be minus 2 and minus 1 2 du, but I have to do the partial fractions as well. This is going to be the step number 5. Step number 5. So 2, there is a u here, 2u divided by u minus 2 into u minus 1. This is a linear. A over u minus 2 plus b over u minus 1. So it will become 2u equals a bracket u minus 1 plus b into u minus 2. In the first step, I'll let the value of u to be 2, which will be 4 equals to a. This will be the value of a, and then I'll let the value of u be 1. So 2 will be equal to b bracket minus 1. So the value of b will be minus 2. So the partial fraction answer that I will have will be 2u divided by u minus 2 into u minus 1. It will be equal to 4 divided by u minus 2 minus 2 divided by u minus 1. I have to replace it over here, and then I'll do the integration with the limits. So it will be 5 and 3. So the first is 4 divided by u minus 2 du minus 5 and 3 2 divided by u minus 2 du. Now I have to do the integration. The 4 is a constant. I'll take it outside. The derivative of the denominator is already in the numerator, so it will be ln of u minus 2. The limits are 5 and 3. Similarly, for the next one, 2 is a constant. I'll take it outside, and u minus 2 ln, because the denominator derivative is already in the numerator, and the limits are 5 and 3. So if I put the limits, it will be 4 bracket ln of 5 minus 2 is 3, and minus ln of 1. Ln of 1 is 0, so it will go away. Minus 2, 2, if I put the limits over here, it will be ln of 3. It is going to be, this is u minus 1. It is going to be 4 ln of 4 minus the lower limit, it is going to be ln of 2. Now if I expand it, this is going to be 4 ln of 3 minus 2 ln of 4 plus 2 ln of 2. Now the 4 is going to go in the power. It will become ln of 3 power 4, 3 power 4, which is going to be 81, minus this is going to become ln of 4 power 2, which is 16, minus this is going to be ln of plus ln of 4. 2 are multiplying, 2 are adding, and the other is just subtracting, so it will be ln of 81 multiplied by 4 divided by 16. If you simplify, the final answer will be ln of 81 divided by 4. So this is the answer. After you need to write it in the rational and in the form of ln. Yeah, that's the end of the paper. I hope you have understood all the questions. If there is any query, please don't forget to ask in the comment section. I'll reply it as early as possible. More videos are on its way, and I'll try my best to explain it at the lowest minimal easy way as possible. Please don't forget to share it with your friends so that it can help them and it can help me to expand and progress in my channel as well. Looking forward for your cooperation. Good luck. Allah Hafiz.